So this is the SV650 engine. It's not the same one that's come out of my motorbike, it's a spare one, which is fantastic because what I wanted to do is I wanted to do a video showing how a motorbike engine works. So as we know, engines need four main component parts. They need air, they need fuel, they need compression, and they need a spark. What this does is it takes the energy stored in fuel and it turns it into a mechanical force, which to you and me means making a motorbike ride very bloody fast up a hill. So what we're going to do is we're going to take the engine apart, we're going to see what's inside it, and we're going to see how it works together. Come on. As mentioned, two really important component parts of the engine working is the air and the fuel. So sitting on top of an engine would normally be the carburetor. The carburetor's job is to combine the fuel and air mixture, and it then enters into the top of our cylinder head up here. So when you pull back on your throttle, what it's doing is it's opening up the carburetor to let more fuel in. That then leads to a higher increase in power. Hence you pull the throttle open and your engine revs. Inside this gap here, you've got the spark plug, and in between that little gap right there, brilliant. So in between that gap right there, that's the part that generates the spark, and that's what ignites the fuel air mixture inside our engine. So we remove these three bolts. Here we go. And that's the top just there, and you can see there's a rubber seal all along here just to keep it all. So what we've got underneath here is we've got our cams, we've got our cam chain, and this chain is running right the way through, down through our engine. Now these cams inside here have a very, very important job. They control the timing of the valves inside the engine. Take that cam chain protector off. So what we've got here, this is the cam chain tightener. So if I undo this and take this out, you can see it's got a long rod here. So effectively what that's doing, you'll see now the cam chain is really slack. If the cam chain loses its tension, it can jump on the cam gears. The cam timing would be out and the valves would open at the wrong time. What this does is it pushes inside this hole against that, effectively makes that solid again. So that's what we can adjust if that cam chain needs adjusting. We take these 6 bolts off. And there we have it. So there's our cam. Carefully take that out. So you can see on here that this cam has got lobes on here. Yeah, so as it rotates, it's going to push down onto these. Now what that's going to do is when it pushes down, it's going to release, it's going to push the valves down. It's going to open the exhaust valve. This releases the exhaust gases from the combustion chamber. I've actually taken one of the valves out so you can have a proper look at it. It's why it's not here. Let me go and grab that one for you. What you can see from this point here is down like this. And this is it. This is the valve. This is the valve that goes down into our engine. So if we take that head off, you can see inside there a little silver disc. That silver disc is called a shim. Okay, and the reason it's got a little disc in there is that's what we can alter. You've probably heard of something called valve clearances. Well, what that means, valve clearance is measured from the cam in its closed position to the bucket. Too little gap and the valve won't close, but too much of a gap and it won't open properly. All right, take the other top off. And that's going to release the other cam, in this case the intake cam. It's got the same lobes on here to push down on here, which is going to cause the intake valves to then open, which allows the air fuel to come into here and then into our main combustion chamber. With all of the relevant bolts removed, we should be able to, excellent, take this off. Okay. There's the gasket that's holding on there, so we'll move that out of the way. Here we'll see, these are the valves that I was talking about earlier, and this is the top part of the combustion chamber. So you can see here You've got the intake valves right here. You've got the exhaust valves right here. So what you see here is the very top of the piston. We can take the cam chain guide out, and then 2 little nuts there. Excellent. Brilliant. That is our combustion chamber. So that is the part the piston runs up and down in. And there you see, there's the piston itself. On a V-twin engine like the SV650 has, the pistons are literally arranged in a V shape, hence V-twin. So I mentioned at the beginning that an important part of the engine process is compression. So I've taken them off for the purpose of taking the engine apart, but what happens on pistons is they actually have these piston rings around the outside of them, and the reason for that is it makes sure that there's absolutely no gap between the combustion chamber and the piston head. And the reason that's so important, of course, if there's a gap then air could get through, which would mean you wouldn't get such high compression. What becomes really important then is to maintain good and regular oil changes, because of course once all of this is all lubed up, then the piston can move freely within the combustion chamber, and the piston rings, because you'll notice here, put together, you'll notice they've got slits in them here, so they'll literally squeeze together. Yeah, so it'll form a nice tight seal around that piston as it slides up and down in the combustion chamber. The piston here is connected to the crankshaft, which is a long shaft that runs through the middle. So effectively your piston and your crankshaft, they're all about creating the power. The up and down motion is then converted into a rotational force. The other side of the bike, which we're going to look at now, which is to do with the clutch, and we're going to have a look at the flywheel and the magneto on this side. This is about actually using that power that's being created, but the raw power is made in this part here. So here we've got the sprocket, which is what links onto the main chain, which goes to the rear wheel. And here we've got the clutch linkage. So we're going to take this off, and we're going to take this front cover off as well. If we go to pull this off, it actually has quite a bit of resistance to it. If we keep going, right, and that's because of the massive magnets that are in here, this magneto, an awesome part of physics. With these electric coils, as there is motion, it actually creates a current, and this current is what charges our battery. And this is the main crankshaft, which is running right the way through the engine, which is connected to the piston. So as I rotate, making sure I move the cam chains out of the way so they don't get stuck, as I rotate the engine, you can see the pistons coming up and down. Okay, I wanted to show you how the bike actually started in the first place. So on the other side of here, you've got the starter motor, and what the starter motor does is it gets this little wheel here to spin up. See that little wheel there? And what this does is it makes the flywheel spin, and this flywheel is this great big wheel right here. So the flywheel is all about even power distribution. So as the piston comes down from the cylinder head, so as the piston comes down from the combustion chamber, which is where all the power is coming from, and what the flywheel does, it takes all 4 stages of the engine and it evens out the power distribution. So the power coming from the flywheel means that our motorbike isn't accelerating and juddering every time that the piston comes crashing down after the combustion phase. So here we've got the clutch cover, so we're going to undo all of these. Also worth noting, of course, if your engine is still in your bike and you want to take a look at your clutch, make sure you take the oil out first, otherwise you're going to coat your driveway. So I've undone one of these so you can see how all of these are connected to a great big spring, and what this does is it compresses this clutch plate together. The reason a clutch is so important is basically a clutch takes the power the engine creates and it makes it usable. So for example, where you've got the piston up here boom, 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 yeah, creating loads and loads of rotational force. Well, that's great if you want to travel at exactly the same miles per hour in exactly the same direction all of the time. The clutch means you can enable drive. It also ensures smooth gear changes. So what a clutch does is it takes that raw power created by this top end of the engine and it actually makes it usable. So what I'm going to do is I'm going to undo all of these spring-loaded bolts here so that I can take this cover off and you can have a look at the friction plates inside. So, take that off. And this is so cool. This is where it gets exceptionally cool. The outer basket, this one here, so you've got an outer basket and you've got an inner basket. The outer basket is always spinning because that's the part that's attached to the crankshaft. So the crankshaft's connected to the piston's going up and down creating the power. So the outer basket is connected to that crankshaft, so it's always spinning. The basket is connected to the gearbox input shaft. This is then linked to the sprocket that drives the chain connected to the rear wheel. So these two plates can move independently. So if you look here when I take these friction plates off, okay, see how they come in different layers, and you see this material on here. Well, that's friction plating. So what will happen, the outer connects to this outer basket. The inner ones here connect to this inner basket, and this process of friction, so when they are sandwiched together really strongly, so to begin with this outer basket is always moving, this inner basket isn't moving. As they're sandwiched together and the friction makes them move, they'll move together as one. So what you've got is a gradual release of power from the piston and the top end part of the engine into the transmission part. So as you get that friction causes, it all catches, and that inner basket is going to move at the same time as the outer basket. When you disengage the clutch, what you're in fact actually doing is releasing the spring. So this clutch basket here, this is connected to the clutch release mechanism on the other side. In fact, I can show you. So when I push the clutch on the other side, see that? All it's doing is it's separating those plates, it's disengaging those plates. So this outer basket is always going to spin. It's going to spin at the same speed that the engine gives it power. This inner basket, based on this process of friction, it's going to gradually build up to be the same speed and power as the outer basket, thereby releasing the power to the back wheel. That's why when you take off from a traffic light, you can gradually build up your speed. Yeah? See how this clutch basket here, look at that. How awesome is that? So you can see the inner plates there with their teeth, you see the outer plates there with their teeth, and it's literally just friction moving the two together at the same speed, which is what's going to rotate. So here we've got the water pump, which is particularly well known in SV650s for corroding, so we're going to get that one taken off as well. How cool is that? Okay, time for a little bit of a summary. So, fuel and air mix is coming into the top of the cylinder. It's coming in via the carburetor, which is mixing the fuel and air ratio. That's then going down into the combustion chamber. The spark plug, which is the bit that sits in the top here, this spark plug is what generates the ignition source, which lights the fuel and air mixture, which then pushes this piston back down into our engine. Once the piston moves back down into our engine, it's connected to the crankshaft. The crankshaft is connected to the flywheel. The flywheel is what keeps the engine, it's like a powerhouse of the engine, keeps it moving even when there's not direct power to it. From the crankshaft, it then connects directly to the clutch. The clutch is what makes that raw power usable, so you're not just travelling at a steady 40 miles an hour no matter what. The fact we can slow down when we get to a traffic light. So by engaging or disengaging your clutch, which is this part here, we can bring together those frictional plates, and when those frictional plates rub against each other and then move together at the same speed, the inner basket and the outer basket are moving in the same speed. When this inner basket is moving, it's turning here, the sprocket at the back, which is connected to our chain, which is what makes our bike drive. I hope you enjoyed watching the video as much as I enjoyed taking the engine apart. I thought it was pretty cool to be able to see the inside and see how it works. So the next time you pull back on that throttle and you hear your engine roar, hopefully you've got a slightly better viewpoint as to what's actually happening inside that engine of yours. Hope you enjoyed it. Remember to like, comment, subscribe, leave me your messages. I will try and reply. Thank you very much. There's the upstroke, and as that piston drives down into the engine, oh, nearly took my fingers off.